Hi all, we're Minerva, the team from Imperial College London, England. We're really excited to be presenting to you all our microcantilever biosensor, which will be used in the detection of free valproate. A company called Avacta have engineered protein scaffolds to be used in an alternative to antibodies called aptamers, which have none of the limitations commonly associated with antibodies. Avacta make custom aptamers using an online service and offer a strategic licensing agreement to customers who would like to use their aptamer technology in their products. Aptamers can be chained together and can also be immobilized on surfaces such as beads or plates. In the case of our sensor, we will immobilize the aptamers on the SU8 cantilever surface. The scaffold protein used in aptamers is adherin, which can be shown in these images. The images have been coloured depending on the secondary structure of the protein, so the helixes are shown in red and the loops in green and the chains in yellow. The two green loops at the top of the protein structure are the variable region. And by changing the amino acid in this sequence, the protein is not destabilized nor the overall structure changed. After making small changes, a series of proteins will be produced that can be screened against the specific molecule. In our case, it will be valproate, to determine the best fit. As aptamers can be more specific than antibodies, the non-specific binding in our sensor will therefore be very minimal, providing accurate results, as well as minimising issues around shelf life and stability of the reagents.
The microcantilever base is made up of 500 micrometer thick silicon wafer. Due to wet etching, there is a top and bottom layer of low-stress nitride layer to protect the piezo-resistant component and act as a blocking mask. Following is a 4 micrometer polymeric layer of SU8. We chose this less commercially used material as it makes creating disposable strips more affordable. It also has a low elastic modulus, resulting in a greater deflection. The piezo-resistive layer is made up of 120 nanometer thick polysilicon. A layer of gold and chromium nanoparticles is to allow an electrical connection of wire bonding. To prevent the electrical components interacting with the ionic solution, a 600 nanometer thick nitride film is laid above. The final part is a smaller layer of gold and chromium where the SAM, made up of 8-mercaptooctanoic acid, and the Avacta technology is deposited on. To process the generated signal, we'll be using a Wheatstone's bridge and an amplifier into the microcontroller to calculate the concentration. Our cartridge contains a custom microfluidic chip designed to move 10 sets of 3 droplets individually to the microcantilever using 4 syringe pumps. A drop of wash is pumped through the channels to wash any leakage and calibrates for a 0 concentration reading. The first drop does this with a known concentration of VPA to calibrate the microcantilever for the reading. The second drop is the patient's actual blood sample to be compared with the reference. The third drop is the wash to clean the cantilever for the next set. Whilst each drop at the cantilever, FVPA molecules diffuse to the aptamer surface and give a reading. During the short time needed for the molecules to diffuse from within the drop to the lever, the bound VPA molecules will not dissociate from their binding molecules in a significant amount. This slide shows how the overall device would look.
So we have used React Native software, which has allowed us to use one set of code to create an app suitable for both Android and iOS devices. This means that no one should be left without the ability to use our app. The screenshots on this slide show what the main features of the app will look like on an iOS operating system and the navigation alike.
Finally, the use of a microcantilever also allows the device to be easily upgraded and maintained, and with developed aptamer technology, the sensor can be adapted for sensing for a variety of drugs in the blood, making this one of the few biosensors that can be used by many different kinds of patients.